the house. Today, we're doing Math Analysis, Chapter 5, Section 3, Part 1, the double angle identity. I'm your host, Dr. D. Okay, so the next part is the double angle identities, and this really comes from the sum of the angle identities. So sine of A plus B we know equals sine A cosine B plus sine B cosine A. Now, let's make A and B the same angle. So we'll just make A theta and B theta. So now you'd get sine theta times cosine theta plus sine the other theta cosine the other theta. Well, so notice what happens. You just sine theta cosine theta plus sine theta cosine theta is 2 sine theta cosine theta. So here's our first identity. Sine of 2 theta is 2 sine theta cosine theta. Now, let's go on to the cosine of 2 theta. So cosine of A plus B is cosine A cosine B minus sine A sine B. So if we put thetas in, we have cosine theta minus sine theta. So that's cosine squared theta minus sine squared theta. Now, because we can change sine squared into 1 minus cosine squared, and we can change cosine squared into 1 minus sine squared, then we can also change the cosine squared minus sine squared. We could either make it all cosines, so make it cosine squared minus 1 minus cosine squared, and that's going to be, notice, cosine squared minus a negative cosine squared. That's 2 cosine squared minus 1, so 2 cosine squared minus 1, or we could change everything into sine, so we're going to change the cosine squared into 1 minus sine squared. So now I have 1 minus sine squared minus sine squared. That's 1 minus 2 sine squared. So the cosine 2 theta, there are 3 different identities that you need to know. You could know cosine squared minus sine squared, that's 1 of each, or nothing but cosine, or nothing but sine. And all 3 will be handy in different identities. Okay, so let's cruise onward to the tangent identity. Tangent of A plus B equals tangent A plus tangent B over 1 minus tangent A tangent B. So if I make these thetas, I have tangent theta plus tangent theta over 1 minus tangent theta. So that's 2 tangent theta over 1 minus tangent squared theta. So that gives us what we call the 3 double angle identities. Forget if I wrote them out. No, I didn't put them all on one screen. Okay, so let's go over them one more time real quick. Now you can freeze the screen and take a look at it for yourself. But we have sine 2 theta equals 2 sine theta cosine theta. Then we have cosine 2 theta equals cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. Now the way I look at this is cosine is the home team, so the cosine is positive, and here the sine is negative. And then the third one, we've got 2 tangent over 1 minus tangent squared. So I'd say it would be a really good idea to memorize these identities.
That's the smartest thing I've ever heard anyone say about anything.
Okay, so let's try some examples. If sine theta is negative 2/3 and theta is in quadrant 3, we need to find sine 2 theta, cosine 2 theta, and tangent 2 theta. Okay, well, let's look at the angle in the 3rd quadrant. So opposite is 2, and hypotenuse is 3. So here's 2 and 3. Now what's the adjacent side going to be? Well, 9 minus 4 is 5. So the adjacent side has to be square root of 5, and it's got to be negative because it's left. So now we have everything. So sine 2 theta equals 2 sine theta cosine theta, which equals 2 times sine theta, which is negative 2/3, times cosine theta, which is negative square root of 5 over 3, so the final answer is going to be negative times negative is positive, 4 times square root of 5 over 9. That's it. Sine 2 theta is 4 square root of 5 over 9. Now, what about cosine 2 theta? Well, that equals cosine squared minus sine squared. So, cosine squared, well, remember we said cosine is negative square root of 5 over 3. When I square that, I get 5/9. And squaring a negative makes a positive. And sine is negative 2/3, so when I square that, I get 4/9. So, oops, it's 5/9 minus 4/9. Yeah, so sine squared minus cosine squared is 1/9. Or I'm sorry, cosine squared minus sine squared is 1/9. That's it. Okay, now tangent 2 theta is 2 tangent theta. Well, what's tangent theta here? It's negative 2 over negative square root of 5. So 2 times 2 over square root of 5, negative times negative is a positive. So that's 2 tangent theta over 1 minus tangent squared theta. So if tangent theta is 2 over the square root of 5, then tangent squared is 4/5. Okay, so this equals 4 over the square root of 5, all divided by 1/5. So that equals 4 over the square root of 5 times 5 over 1, which equals 20 over the square root of 5. And we are not like the godless heathen who leave radicals in the denominator. So this becomes 20 square root of 5 over 5, and 20 over 5 is 4. That's it, game over. So basically, you just have to know your identities, and then it becomes fairly simple. Okay, now, verify that cosine 3 theta equals 4 cosine cubed theta minus 3 cosine theta. Now, the thing that I would recommend here is, notice on the right side, it's simple. On the left, it's going to be complicated because we've got a sum of angles. So what we're going to do is just work with the left. And the other thing we know is we want the cosine identity that has all cosines. Okay, so cosine 3 theta really equals cosine of 2 theta plus theta. Okay, that equals cosine A cosine B minus sine A sine B. See, cosine 2 theta plus theta, cosine cosine minus sine sine. Okay, now, what is cosine 2 theta? Well, it's cosine squared minus sine squared, but we don't want that because we don't want a sine squared. Or do we? Let's see. Yeah, let's just keep it all cosine since those are cosine. But so what we want is 2 cosine squared minus 1. So 2 cosine squared minus 1 times cosine. Now sine 2 theta is 2 sine theta cosine theta times the other sine theta that's just hanging out. So when we distribute this, we end up with 2 cosine cubed theta minus cosine theta. Now what we have here is 2 sine squared theta cosine theta. Now we're getting close, but we need to get rid of that sine squared. So we need to turn it into 1 minus cosine squared. Okay, now I have nothing but cosines. So now what I have to do is just distribute this. So so I have 2 cosine cubed theta minus cosine theta. Now I have minus 2 cosine theta times 1. So it's minus 2 cosine theta. And now I have minus 2 cosine theta times a negative cosine squared theta. So that's going to be a plus 2 cosine cubed theta. All right, so now let's count up our cosine cubed thetas. We have 2 plus 2, so that's 4 cosine cubed theta. And now how many cosine thetas do we have? We have negative 1 minus 2 is negative 3 cosine theta. That's it, QED. Okay, now, remember, the key thing here was to go from cosine 3 theta to cosine 2 theta plus theta, and now you have the sum of the angle identities, and then you're going to have a cosine 2 theta and a sine 2 theta, so you need to know those identities, and then it's just a matter of algebra. Oh, just one more simple trig identity, sine squared equals 1 minus cosine squared, but really the rest is just algebra. So that's it. Cruising onward. One more example problem, and that is we need the exact value of sine 15 cosine 15. Now, this is going to be actually fairly simple because you see that we have sine theta cosine theta. So we could say that 2 sine theta cosine theta equals sine of 2 theta. There's your identity. 2 sine theta cosine theta equals sine of 2 theta. So that means 2 times what we're looking for equals sine of 30 degrees. Well, sine of 30 degrees is 1/2. So if I want to get sine 15 cosine 15 alone, all I do is divide both sides by 2, and I have sine 15 cosine 15 equals 1/4. That's it. Game over. So have fun with these.